So into our question period here. All righty, this is the first in a series of 4 talks on, this talk is about the network value-added attributes. We want to understand how the VAs are created and their dependency on the NHD service water network. We want to learn about the navigation attributes in this talk, and we want to learn how to obtain, install, and use the value-added attribute Navigator. The VA Navigator was one of the tools that was provided as part of the workshop download. I hope some of you were successful in getting it installed. If you were, when we do our hands-on tomorrow, you'll get an opportunity to use the VA Navigator. Okay, we'll talk about the fundamentals of the attributes. We'll talk about the details of the ones that are related to flow lines. We'll talk in particular the subset that is related to navigation, and we'll talk about the Navigator. All right, the fundamentals are really important. All these attributes are computed. Nothing is collected here. And they're computed from the NHD, the plus flow table. So if 2 flow lines relate in the plus flow table, then they are going to have attributes that value-added attributes that reflect that connection. The attributes are built upon each other. They depend upon the flow table being accurate. We have a QA/QC process that is very rigorous. The QA/QCs the flow table against the network. It doesn't mean that the network is completely right. You could have the network flowing in the wrong direction, but if everything is flowing in the wrong direction, then it's right as far as QA/QC is concerned. We try not to have that happen. If the data doesn't pass QA/QC, you can't compute the value-added attributes. One of the value-added attributes is stream order. People have been wanting stream order on, NHD for a long time, and everybody says, well, maybe we could get the software for computing stream order. Unfortunately, it doesn't work that way. First, you have to pass the QA/QC, and then you have to start computing this whole suite of value-added attributes in order to get stream order. It's not just a standalone utility. They are computed for a complete drainage area. So the Mississippi drainage, which is a handful of hydrologic regions, is all consistent in terms of its VAAs. There are a number of identifiers in the VAAs, and all of them are nationally unique. And these attributes are stored in a table called Plus Flowline VAA. There are 3 groups. One is just attributes that are associated with the flow line itself. There's the navigation attributes, and then there's a subset of attributes that are used for analysis. We're going to focus on the navigation attributes here, but I wanted to tell you that we replicated, to make it easy to use the Plus Flowline VAA table, we replicated some of the NHD Flowline attributes in that table. We put the reach code in there. We put the length KM, those 2 attributes, and the F code. Those 2 attributes are actually also in NHD Flowline. But the other thing we did was we exposed the from and the to measure. Measures are stored on the coordinates as M values. So you have X, Y, and if you have 3D, you would have Z, and then you have an M value. That's where the measures are, but you can't see them. So we expose the from and the to measure for each flow line within the VAAs. These are the navigation attributes. We tried to put something in here for everyone. There are a lot of models that use from and to nodes, so we generated a set of from and to nodes. The nodes in NHD Plus are conceptual. There's no point feature class called the nodes. But in the BAA table, there's a from node attribute and a to node attribute, and those link those records together. So you'll go from this from node to this to node, and then that to node is the from node of the next one down. So models that use from and to node navigation, there it is. There's a start flag and a terminal flag. So the start flag tells you all the network headwaters. So it's a really easy select to find the network headwaters. The terminal flag tells you where the networks end. There is a VPU in and VPU out attribute, and in the Mississippi and the Colorado, if you're trying to find where you're moving from one VPU to another, those two attributes will tell you. And they tell you not only what VPU you're leaving, but what VPU you're going to. There's stream level. We'll talk about these in more detail in a minute, so I won't get too tied up in that. There's a divergence attribute. Then there's some upstream and downstream attributes that are primarily there for the value-added attribute navigation. Okay, so here's from node and to node. It's a set of unique identifiers for the node endpoints of the flow lines. So at the point where two or more flow lines come together, there is a node number. There's a node number at the top, at the start of every network. Every headwater has a node number. The terminus point of a network has a node number. It's a compact numbering system. So if you want to load it up into an array and you want to use it as the bounds of the array, you can do that without a lot of trouble. There aren't big gaps in the numbers. The start flag just indicates that it's a flow line headwater. The terminal flag indicates that it's a flow line terminus of a network. VPU in and out, we just talked about. Stream level. This is an old reach file version 1 concept. Basically, it is a concept that starts at the bottom of the network and tries to follow the main stem of the network upstream and assign a consistent stream level. So every stream that discharges into the ocean, like the Mississippi, starts at 1. If you follow the Mississippi to its headwaters, it'll all be stream level 1. The Ohio discharges into the Mississippi, it becomes stream level 2. The Tennessee discharges into the Ohio, it's stream level 3, and so on. Stream level follows the name wherever it can. So if there's a named feature upstream, the stream level follows that. If there is no name to follow, for example, maybe there are names, but it's a new name, like the West Fork and the East Fork come together to make the Black River. When you get to the top of the Black River, it has to decide which is the main stem. And there's no real name to follow there. The name has changed. It uses a concept called arbolet sum. The arbolet sum is the total number of stream miles that drain to that flow line. All the upstream flow lines, their lengths added together. And it follows the maximum arbolet sum when it cannot follow name. Okay? There are almost 60,000 flow splits in the NHD Plus network at 100K. And I have to tell you that I was just looking at a HUC4 at high res where there were 5,000 flow splits just in one HUC4 at high res NHD. So this is not a dendritic network. At the flow splits, NHD Plus tells you what it thinks is the main path downstream. And it values an attribute called divergence. And if divergence is 1, that is the main path downstream. All other paths downstream, and there may be more than one. We have one place where it splits into five paths. They will all be divergence equal 2. Divergence of 0 just means that it's a flow line that doesn't participate in a split. These are the main path divergence rules, and they're somewhat arbitrary other than name. It too follows the name. And we want, when you're going upstream using stream level, we want you to be following the same path that you follow downstream using divergence. So divergence and stream level are in sync with each other. Both of them use name as their primary method of choosing. If there is no name to follow, NHD Plus has a table called DivFrac-MP, which stands for Divergence Fraction Main Path. And it allows you to do a couple things. If you don't like the way NHD Plus chose the main path, you can set the main path in this table. And our Sparrow modelers did that for a whole bunch of places in the country. So if you look at DivFrac-MP, you'll see places where they overrode what the NHD Plus would have otherwise chosen given its set of rules. The other thing you can do with DivFrac-MP is you can split the flow. It's assumed in our flow estimation that without any other information, 100% of the flow goes down the main path, mainly because we have no other information to make a decision. But if in the DivFrac-MP, you can say 75% goes down this path and 25% goes down this path. So if you have gauge data and you want to split your flow, this is how that happens. If it can't follow a name, it navigates downstream from all the paths and it says, do any of them flow to the coast? And if one of them flows to the coast, it becomes the main path. If more than one of them flows to the coast, then it continues on. If it's a named flow line that flows to the coast, that's picked. If there are no names, then it picks any named flow line as the main path. And if there's no other information, it just picks a path. And there are places, obviously, where it has to do that. Hydrologic sequence is another reach file version 1 concept. It is a unique national number that puts the flow lines in upstream to downstream order so that you can process them tabularly with a program, sort them on HydroSeq. If you sort descending, you're going from upstream to downstream. If you sort ascending, you're going from downstream to upstream. And what it guarantees you is whatever flow line you are looking at, you're guaranteed to have processed everything either upstream or downstream, depending upon which direction you're processing the file. You will have also processed a whole bunch of other things, okay, but you know that you've processed everything upstream. The Sparrow model and other models that have been around for many years use hydrologic sequence number to process the file. They don't trace the geometry. They just process it, they save the results at a flow line, they read to the next one, and whenever they process a flow line that has something coming in, they go find the saved results of the things coming in and continue on. It's a pretty handy attribute to have. Also, it is a compact numbering system, so you can use it as an array index if you want. There are 5 upstream and downstream attributes within the BAAs, so that when you're sitting on a flow line, you have some preview of what's upstream of you and what's downstream of you. You know what the upstream hydrosequence number is. You know what the downstream hydrosequence number is. If you're looking downstream, you know how many flow lines are immediately downstream, so you know whether you're about ready to go into a flow split. You know what the minor hydro sequence number is. So for the vast majority of flow splits that are just two paths, the main path and a secondary path, you have both hydro sequence numbers in the VAAs. And you know the level of the downstream flow line. So this tells you when you're at the bottom of the Tennessee, the downstream level is going to be a 2 and the Tennessee is a 3, so you are just now coming to the discharge of your stream and you're about ready to be a tributary into a bigger waterway. All righty, Flow Table Navigator. And this is a picture of the Horizon Systems NHD Plus website, which is still a live website. We hosted the website for EPA for a long time, and this past year EPA has gotten their website going, and a lot of the links and so forth that you've been seeing are to that website. That is the official website. Everything on the Horizon Systems website is still there, and it's current. And we just didn't have time to change all of our pictures. So there's a VAA Navigator on the tools page, and it's on the EPA tools page, and it's on this tools page. You can download it. There's a user guide and instructions for how to install it. The NHD Plus desktop tools have some sort of heavy requirements. They're all built in .NET. And for SQL, for the heavy lifting that they do relative, and they need SQL, they use Microsoft SQL Server Express, which is a free tool. So in order to run the tools, you have to install SQL Server Express. It was provided in the workshop data, and there were instructions there for installing it. It's not difficult to install, but you do need to have admin privileges, or you need to go and bend the knee to your network admin and get them to do it for you. So you need .NET, you need ArcGIS. Nominally, the tools were all tested and working in 10.2.2. However, we have tested them in 10.3 and 10.4, and they work. Are they thoroughly tested in those two versions? We don't know of any problems, but I would not say they're thoroughly tested in those versions. If you find any problems, we'd really like to know. You need SQL Server Express Local DB. There are links to all these components on the website, and you need the BA Navigator toolbar. All these things come as 7Z files, so you download them, you uncompress them, and you run the install EXEs to get all the pieces installed. Once you have it installed, you have to add the toolbar to ArcMap as a custom toolbar. If you right-click on an empty place in the ArcMap toolbar and click Customize, you'll come to this dialog. Choose Add from File, navigate to where you installed the toolbar, pick the TLB, and it will, if it works, it will give you a response like this. There are some permissions issues, and particularly that started when Windows 7 came along, where you'll get back an Added Objects window that says no objects added. That's a permissions thing in Windows. If you have the ability, you can right-click, get out of ArcMap, right-click on ArcMap, and run ArcMap as administrator, and then this will work. If you don't have the ability to do that, you're back to your sysadmin folks to help you. Okay, there are 4 tools on the toolbar. Upstream main stem, upstream with tributaries, downstream main stem, downstream with diversions. Okay, the only thing you need in your map is NHDFlowline. You do need the NHDPlusAttributes component as well, but it is used in the background. All you have to do is have it downloaded and installed. That is described on the website. Your data requirements are described on the website and in the user guides that come with it. When you pick a tool, one of the 4 tools, and you zoom in so that you can see your flow lines, and you point and click at a flow line, you get this dialog. And the very first thing in the dialog is the Navigator database path. The VA Navigator, the very first time you use it in the VPU, it builds a SQL database that it then uses from that point on. So the first navigation is a little slower than all the rest, but that database is built one time, and then it's used every other time that you navigate in that VPU. And it needs a place to put those databases, and it asks you to tell it where you want them to go. You need to have read-write access to this path. Okay? Then there's some start options and some stop options that enable you to use full flow line navigation, which is a start option, or you can start right at the point where you click. It'll do point level navigation. The stop options include distance. You can say go 50 miles. You can go 50 miles downstream. You can go 50 miles upstream with tribs, and it goes 50 miles up every path. There are a handful of attributes that it also allows you to stop with, one of which is drainage area. You can say, navigate upstream until my drainage area falls below a certain threshold, and it will do that for you. Okay. So the navigation databases are created once, used many times. This is a picture of the start options. If you select start at top or bottom of clicked flow line, it includes the whole flow line. Doesn't matter where you clicked, it'll include that whole flow line in your navigation. If you're going downstream, it starts at the top. If you're going upstream, it starts at the bottom. Or you can start exactly at the reach code and measure where you clicked. Here's an example of an upstream with tribs navigation. You notice that it didn't include the full flow line. We don't seem to have any pointer capability here. Okay, the black dot is just a graphic on the screen that the Navigator puts there. It's not part of the data. You'll notice that it creates a layer in your map called navigation results. This is an in-memory layer. So if you want these navigation results, you have to export them and save them. If you navigate again, it'll replace those navigation results with your next navigation. Stop, as I said, you can stop at 50 kilometers. Here's a picture, and you can see at the top of this network that it stopped before it got to the top of every path. And you can be guaranteed that from your starting point to where it stops is exactly 50 kilometers on that path. Here's the drainage area stopping condition. So you can say, go upstream until the drainage area falls below 50 square kilometers. We started at the same spot here, and we're navigating a lot fewer flow lines because it doesn't go up all the little tributaries, which have very small drainage areas. Just as a review from what Tim said, our linear...
Go ahead and have a little tip where you can actually go over here.
Getting tech tips here.
Right, yeah, see the mouse over There it is.
Ooh, okay. I'll try not to use that. Okay, well, the route system in NHD, I have to remind you because the navigation results come back as an event table. Because they do point-to-point navigation, they can start in the middle of a flow line, they can end in the middle of a flow line. It comes back to you and it says, here's the flow line, but I only navigated from this measure to this measure on that flow line. So you remember the reach code and the measures. They start at 0 at the bottom of the reach and end at 100 at the top of the reach. Here is the picture of the navigation results. You get the COM ID of the flow line you navigated. You get the reach code. You get the from and the to measure. And you notice we started in the midst of a flow line, so that first record started at 17, the measure of 17. It ended at 100, but all the ones upstream we did 100%. So they're all 0 to 100. The other thing you get is the hydro sequence number for each of the flow lines. So you can sort these in hydrologic order if you have some reason to do that. Here's upstream main stem and upstream with tribs, just pictures of those. Here's downstream main stem and downstream with divergences. So you can see in the circle there was a little flow split, and it followed both the paths. If you said downstream main stem, it follows what it thinks is the main path. And that is the end of VA navigation and VA navigation attributes. Are there any questions? Yes. No, there is no
question. Sorry.
Okay. The question was, can you provide to the navigator a stop, reach code, and measure? And the answer to that is no. We have never implemented an option like that. Howsoever, the navigator is a callable thing. You can call it from Python. And in the documentation, there's code snippets to do that. You can also call it from .NET or any other COM-compliant language. And if you're calling it yourself, there are a whole lot of things you can do that this interface, this toolbar interface, doesn't expose to you.
Cindy, I'm wondering how comfortable you would be if somebody came to you and said, hey, can you do hydro sequencing to do Strahler's stream order?
Well, the stream order in NHD Plus is a variant of Strahler stream order, okay? We'll talk about stream order in one of the other attribute presentations. But Strahler and all the stream order algorithms, for that matter, are dependent upon having a dendritic network. And as I said, there's 60,000 places where it's not dendritic. So we had to come up with a technique for handling those diversions. And there is a technique, and there'll be some pictures that'll be shown on how that is applied. And Barb Rosenbaum, do you want to stand up? That's Barb and her colleague came up with this technique, and we wrote the software, and that's how stream order was done in NHD Plus. It should give you, it's designed to give you the same stream orders you would get if you had a dendritic network.
Oh. Over here. Question that I had, well, this is an issue that I had that I didn't get documentation for, but I installed the tools on a Forest Service computer, and it shut down installing it because there's no updater access allowed on Forest Service equipment. And so it was not installing correctly on my Forest Service machine. So I'll work with you guys to figure out what that is and what's causing it. It's probably because it's a Forest Service image.
Okay. This makes the tools a heavy bar for folks, particularly government folks who have computers that are so locked down. But we're trying to make it easier and easier to do that. One of the things we've been looking at is converting the tools to ArcGIS add-ins, where you don't actually have to do an install. And that's more difficult than it looks if you're doing SQL.
Excuse me, that you showed that when the navigation, you can stop the navigation along the stream below certain drainage area, is it right?
Yeah.
For example, 50 square kilometers. So, I mean, it means that you have a function of the stream length versus the drainage area in your data, is it right? How we could do that, I mean, we are.
Okay, I'm not sure I understood the question.
You know,
Curtis,
I
did you hear
in
it?
navigation that we can stop the navigation along the stream below certain drainage area.
Yes, you can do that.
50 square miles. So to do that, it means we have the data in the system that actually has the drainage area versus the length of the stream. Is that right? Do I understand correctly?
The drainage area for each flow line is computed from the catchments. So we've accumulated the catchments down the network. So for every flow line, we have its upstream drainage area. Was that?
And the question was, does the interface include that? Could you trace down to a certain drainage area?
Oh, downstream. Right. I'm sorry.
Right. And stop when you get to a certain drainage area. It sounds like you could do it with the Python stuff or some other interface.
You can do it with this interface. You just have to get your equation correct in the window of options. Mm-hmm. You'd want to pick total drainage area, and you'd want to pick, you know, stop when it gets greater than a certain amount, and then do a downstream navigation, and it'll stop when it gets greater than. The important thing about that capability is that it evaluates at every single flow line. So you have to make something logically usable depending upon which direction you're going. Going upstream and stopping when it gets small, or going downstream and stopping when it gets large, those make sense. Vice versa, they don't. You wouldn't go anywhere.
I was wondering how, in agricultural areas, how the idea of a diversion and then a return flow would be treated in the context of like divergence and navigation and the tools that you just described.
Generally, the NHD snapshot is natural stream flow. Well, natural stream flow, but with dams and things like that. Not many canal ditches are actually included in the network, and they're only included when they're necessary to connect up the natural drainage. However, we've got some tables that called plus flow AR, and AR stands for additions and returns. And it enables you to populate those and say, at this point, there is a removal, and it goes off, and it's agricultural, so it, you know, is used for agriculture, or it's a drinking water intake and it's consumed in that way. Or you can route it out and route it to another place in the network. That table is not well populated. We have a few entries in it, I think maybe 300 for the whole country, but you could put a lot of data in there. Any other questions? Okay.
Okay, wow. Is this better? Okay, just one thing I wanted to mention, and as many of you know, we are working on a high-resolution NHD Plus. We'll talk more about that tomorrow, but I wanted you to be aware that we are working on issuing a challenge grant, which would be basically aimed at trying to illustrate how high-res NHD Plus would benefit some kind of an application over the medium res NHD Plus, which is what you're learning about today. And so I just wanted you to be aware that that challenge grant will be coming out sometime. We haven't finalized the details on it, but if you're a programmer and you want to do some cool stuff, just watch for that challenge grant to come out on challenge.gov sometime in the next month or two, hopefully. So there will be a challenge grant out on that.
And everything you learn here today is applicable to the high-res NHD Plus.
So a couple of minor items before we go off to lunch. So we were talking about URLs for the web. I need to confirm for those of you who ended up with one of these pins that has that nice URL on the clip, that's not the current URL. The pin works great, and it will for years, trust me. So right now it says epa.gov/waters, plural. If you just said water data, replace the S with DATA, it'll take you to the page, the new page. Okay. So Lori's going to give you some recommendations for places.